Chemistry is the study of matter and its changes. We can describe matter by using its properties, and we can also describe different kinds of changes in matter by thinking about what differentiates them. And that's what this video is going to be about: the properties, types of changes. So let's talk about properties first. Properties are ways of describing things. We use properties all the time in our everyday life, although we probably don't think of them as being properties. So, for example, if you observe the color of somebody's shirt, or how their hair looked, or maybe the size of the players on the other team, you would be describing their properties. And we can divide properties into two different types. So some properties are physical properties, and a physical property is something that we can measure or observe or measure, if we look at this sentence here, without changing the sample's composition. In other words, without changing its chemical formula. And what we just talked about a minute ago were some physical properties. So, for example, color is a physical property of something. We can tell if someone's shirt is pink or plaid just by looking at it. We don't have to change its chemical formula. We can tell if something is a solid or a liquid or a gas just by feeling it or looking at it. We don't have to change its formula in order to be able to look at that property. And we've got some other things here that are physical properties, like melting point and boiling point. We can measure the temperature at which an ice cube turns into liquid water without changing the formula of that water. It's still H2O when it was a solid and when it was a liquid. Properties that are not physical properties are chemical properties. So a chemical property is the ability of some type of matter to undergo a specific chemical change. What do we mean by that? Well, what we really mean is a chemical property is whether or not something will react, a sample of matter will react. And maybe we can understand a little better with a couple of examples. So here's an example here. We say that iron rusts. That's a chemical property. Why? Because what we really mean is that iron reacts with moisture in the air or moist air to form what we call rust. And the rust is a substance that is chemically different from the iron. So the property of iron, the chemical property of iron, is that it rusts or reacts with moist air. Let's look at another example here. Oops, need to go back. So in this example here, we say that paper burns, and that turns out to be a chemical property of paper. What we really mean is that paper reacts with the oxygen of the air. We have to start it up by heating it with a match, and it turns into ashes and some gases. So the paper burning is a chemical property. It's a specific reaction that paper can undergo under certain conditions. So we have physical properties, chemical properties. All right? Now we're going to shift gears. Now we're going to talk about different kinds of changes that we might come in contact with during chemistry class. And some changes are going to be physical changes. So, in a physical change, some properties of what we have might change, but the chemical composition does not. Think about that ice cube we were talking about a minute ago. The ice cube is solid H2O. When it melts, it changes its shape. It changes from a solid to a liquid, changes its state of matter, but it's still H2O after it melts. So it changed, but its chemical formula or chemical composition didn't change. Let's think about a piece of glass. I've got this little flask here. If I dropped it on the hard floor, it would probably break. So the shape of this flask will change. But it's glass now, and the pieces that it breaks into are still, or would still be, glass. So the chemical composition of the glass didn't change, even though the property of its shape did change. And that's an example of a physical change. Some changes are chemical changes, and during a chemical change, the composition of whatever material we're talking about always changes. So the chemical formula changes. So the question that we're going to ask ourselves all through the year in chemistry is, how do we know when something is a chemical reaction? So a chemical change and a chemical reaction are the same thing, and we're actually going to use this term more often. So again, how do we know when we have a chemical reaction occurring? So one way to tell is, did the formulas of the stuff involved change? Did their chemical formulas change? So here's a statement that sums up what happens in any chemical reaction. The things we start out with, which are called reactants, turn into the things we end up with, which are products. Reactants turn into products. There's a little bit more symbolic way to write that, and here's an example. And the things that are underlined here, the chemical formulas, are the chemical formulas on the left of the things we start out with in this example of a reaction, and here are the chemical formulas of the things we end up with. And we'll talk a lot more about how we write a chemical equation like this and how we get all these numbers that are in it and so forth. But for now, what we want to see is that the things we have at the beginning on the left-hand side of our arrow have different chemical formulas than the things we have at the end. And that tells us that this is a chemical reaction. The chemical formulas changed. What if we don't know anything about the chemical formulas? And that happens a lot. We might see a change, but we don't know what the formulas are of the things that are involved. And in that case, we can look for some evidence that we have a chemical reaction. So we're going to make a list of 4 different things, 4 different clues that a chemical reaction might be occurring. They're not rules, but they are clues or types of evidence that a change is a chemical change. So one thing we might see is a transfer of energy. The paper that we talked about burning a minute ago, when that burns, we get light and heat that weren't there before. So that energy came from someplace, actually came from the bonds in the substances, and so that energy got transferred into light and heat energy. And that's a clue that that was a chemical reaction. We might see a color change that helps us to know that a chemical reaction has occurred. Not every color change tells us that. If we have yellow paint and blue paint, we mix it, we get green paint. That's not a chemical reaction, but many color changes, significant color changes, are associated with chemical reactions. And when we see a color change, particularly if it goes along with something else, that significant color change is a clue that a chemical reaction has occurred. Oftentimes, if we see a gas being produced, that tells us we have a chemical reaction. If we do a reaction in a liquid, sometimes you'll see bubbles. Those bubbles contain gas. A gas being produced tells us that, might tell us that we have a chemical reaction. Often it tells us that. Some gases have a color to them, and if we see that colored gas being produced, that might tell us that we have a chemical reaction. And the other thing we might look for is the formation of a precipitate. So a precipitate is defined right down here in this last sentence. It's a solid that forms when we combine 2 liquids. So we might have 2 containers, each containing a liquid. We'll see many examples of this through the year. Well, if we see those 2 containers, each containing a liquid, we put them together, and all of a sudden, or it may take a minute or 2, we see a solid formed in that liquid that wasn't there before. That solid is a precipitate, and it's a good indication that what the reaction, the change we're seeing, is the result of a chemical reaction. So 4 things that we might look for that give us evidence that a change we're seeing is a chemical reaction. Now before we finish up this video, we're going to take a look at a couple of things that are, will tell us about tell us something about chemical reactions. And this slide here is giving us an example of this sentence. Here's the key sentence on this slide right here. Oftentimes when we have a chemical reaction, the result is a compound. Compounds are chemical combinations of different elements. And usually, the properties of a compound are much different from the elements that make them up. Here's some pictures about sodium. Here's some sodium metal. It's got that grayish cast to it. Sodium metal is actually quite hard to handle because it reacts violently with water. Sodium, when it's used in certain kinds of lighting, produces a sort of a yellowish kind of light that you see sometimes around cities or big buildings. Here's a bottle that contains chlorine gas. And here's a swimming pool that has some chlorine in it. Chlorine gas is actually quite hard to handle because it's toxic. It's in the swimming pool because a little bit of it will kill many of the bacteria in the pool, and that's what we want. That's what we want, although they won't harm, the small amount won't harm the people. Toxic gas, hard to handle, reactive metal. We put them together, sodium and chlorine. We get sodium chloride, which is table salt, and we're happy to eat it. So we started out with materials that are hard to handle or hard to deal with for various reasons. And we end up with something that has very different properties, different color, solid at room temperature, won't react with water. Doesn't matter if you pour salt in water. It dissolves, but it doesn't react. It's not dangerous. And we can eat it. So the point here is that the properties of this compound, the sodium and chlorine chemically combined, are very different from the elements from which they're made. So the reaction that formed the sodium chloride produced something with different properties. Let's talk about one more thing before we finish up here, and that is the law of conservation of mass. So anytime we have a change, the mass of what we start out with is the same as the mass we end up with. So in any chemical reaction, the mass of the products, that's what we have at the end, is the same as the mass of the reactants. That's what we had at the beginning. There's another way to say the same thing. In any physical change or chemical reaction, mass is conserved. Mass at the end is the same as the mass at the beginning. Whatever we had at the end weighs the same amount as whatever we had at the beginning. Another way to say that is that mass is neither created nor destroyed. So the law of conservation of mass is something that's been observed by scientists over a period of many, many years, and it really helps us to understand and explain what's going on if we know that the mass of our starting materials in any physical or chemical change is the same as the mass of our finishing materials. You know that this wood is heavy. You could probably pick those logs up, but they'd be heavy. And after you burn them, all you have left is a little tiny pile of ashes. How does the law of conservation of mass work there? Well, when we burn this wood, we combine the wood with some oxygen from the air, and we end up not only with ashes, but lots of carbon dioxide gas and water vapor gas that goes up into the air. So the mass of the wood plus the oxygen does equal the mass of the little bit of ashes plus the carbon dioxide and water that went into the air. And the law of conservation of mass does apply, as it does in any chemical reaction or physical change. So there's a little bit about different kinds of changes that we're going to encounter in chemistry class, and how we can say something about the properties of material. Properties of matter and its changes, that's chemistry in a nutshell.